Normalize the quantum state psi equal 3 times spin up times ket spin up plus 2i times ket spin down. How do we normalize this problem? This is from the idea of orthogonality and orthonormality. Or you can just say orthonormality. Let's look at the short way of solving this problem with ease. Then after that, we'll also look at another way of solving it. But let's try to solve it in standard way. So we can say let's see C1 and C2 be the coefficient be the coefficients of 3 spin up and 2i spin down ket respectively. That is if you are trying to solve it in an official way. So the first thing we need to know is, looking at this state, the coefficient is 3. Looking at this, the coefficient is 2i. Our focus is on the coefficient. We are going to calculate for the norm square, and the norm is simply looking for the bra term of the ket term. So we are going to solve for this, and this is equal to the sum of the absolute square of the coefficient of each state given. So in this case, it's going to be C1 absolute C1 squared plus absolute of C2 squared. So what is C1? 3. So 3 squared plus C2 is 2i squared. Since we are looking for absolute term, we know that I is the same as square root of -1. So at the end of the day, the absolute of I is definitely going to give us 1. So we can just focus on the numerical part. So this will give us 9 and this will give us 4. So in total, 4 plus 9 gives us 13. That is 13. So now that we know our norm, just call it norm to be equal to 13. The second part is to look for our normalization constant. And our normalization constant here is equal to 1 all over square root of the norm. First step, look for the norm by summing up the absolute square of each coefficient of the state given. And the second step, you calculate the normalization constant, and it is equal to 1 over square root over the norm. So our norm is 13. So the normalization constant equal to 1 all over square root of 13. So this now is our normalization constant. And the last step to do is to multiply the normalization constant throughout the given state. So let's do that. The state given to us was, how do you call it? Psi equal 3, which is here, spin up plus 2i ket spin down. And we've gotten our normalization constant to be 1 over square root of 13. So we are going to multiply the the normalized wave function is going to be 1 over square root of 13 multiplying 3 spin up plus 2i spin down ket. So this is a normalized wave function. We can go ahead and simplify it. So 1 over square root of 13 multiplied by 3 gives us 3 over square root of 13. Just bring whatever is here, spin up, okay, plus 1 over square root of 13 multiplied by 2i. You just have to focus on the coefficients. It's going to give us 2i all over square root of 13. Then bring in the remaining term. So this is a normalized wave function. A normalized quantum state. So a quick summary. First of all, you have to calculate for your norm, and the norm is equal to the absolute square of each coefficient given, right? And that is what we did here, and we've gotten it to be 13. And the second step is calculate for your normalization constant. Normalization constant equal 1 over square root over the, square root of norm. And our norm was 13, right? So 1 over square root of 13, which is our normalization constant. And the last step to go, the last step to do is to multiply the normalization constant by the given state, which was given to you to normalize. So multiplying through gives us this, and this is our normalized wave function. Another way to solve this problem is looking for the corresponding ket state, bra state. This is given us in the ket state, the one with the greater than sign facing, the greater than sign is what we call the ket state, right? So we are going to look at the bra state of it. So and what we do is that, so we are going to look at we are going to compute the product of the bra and the ket. So this is the bra, so psi then ket equal to, first of all, we write whatever is there, which is 3 plus 2i into bracket. And if we are done, we write whatever is here, but in this case, the operation sign is going to change. So it becomes minus. So we are going to write 3 spin up minus 2i slash spin down ket. So now let's expand it. So we have 3 slash spin up multiplying 3 slash spin up, right? So how do we write this? So 3 by 3, it should give us 9, right? So this should be equal to psi 9. So 9, we have 2 spin ups, right? So we just open bra spin up slash spin up ket, and 3 spin up multiplying minus 2i. So 3 multiplied by minus 2 gives us minus 6i, right? But what do we have? We have spin up and then spin down. So spin up slash spin down. Then we close. So now we go to this term, 2i multiplying 3. So that will give us positive 6i. So we have spin down, spin up. So bra spin up times spin down, close. So now minus 2i multiplied by minus 2i, that is going to give us 4i squared, right? And Here we have spin down, spin down. So bra, spin down times spin down. So what we do next is that we are going to assume that so spin up, spin up, spin up, spin up is going would be equal to spin down, which is equal to 1. And spin up, spin down is going to be equal to spin down, notice the sign, spin up, which is equal to 0. So if we have the spin facing the same direction, they will get a probability of 1. But if they are facing, if one is facing up and one is facing down, we get a probability of 0. So now let's go back to the problem. So we have spin up, spin down here. This will give us a probability of 0. So this term here goes 0. We have spin up, spin down here. This one will also give us a probability of 0. We have spin up here. This will give us a probability of 1. Spin down, a probability of 1. So now let's proceed. Our bra side multiply side get would be equal to. Now our major concern is on this and that. So 1 multiplied by 4, right? Let's start with 9. So we have 9 and here we have 4 plus 4. Even though we have this term here to be 4i squared, but mostly we are interested in the positive part. We know that I squared will be equal to square root of minus 1 all squared. So giving us minus 1, which will affect 4, but we are interested in positive values. So this is going to give us 9 plus 4, which is 13. 13. Then after we are done with this, we calculate for our normalization constant. And the normalization constant is just going to be the same formula. So n equal 1 over square root of bra side multiplying side get. So in this case, we had it to be 13. So equal to 1 over square root of 13. Then when you are done, you just multiply the normalization constant by the whole term. And doing so is going to give us what we already had here, this term here. So if you multiply the normalization constant by the term that was given, original term, this is what you will get. So that is another way of going by it, but I prefer the first step. The first procedure. That is it for this problem. You are done and you want to know whether your solution is right. What you just have to do is to square the coefficients and see whether the sum of the square of the coefficient will give you 1, but it should be the absolute value. So we square this and add them together. So 3 over square root of 13, we are squaring them, and this is 2i over square root of 13, squaring them. So if we square I, we are going to get -1, but because we are interested in the absolute value, it's going to be +1, right? So before that, let's start with this. So square of 3 will give us 9. All on squaring square root of 13 will give us 13, plus square of 2 will give us 4. I will definitely give us +1, so no effect. So square root of 13 gives us 13. So summing up all these turns out to give you 1. This is a proof that your state is normalized. Prove that psi1 equal n1 into bracket a squared minus x squared and psi2 equal n2 x into bracket x squared minus, a squared minus x squared over the interval -k to k are orthogonal. Solution: we have to prove that these two wave functions are orthogonal. And the general definition for orthogonality is that if we take integral with a given interval, let's say negative infinity to positive infinity of psi 1, psi 2, dt, and we've gotten our answer to be 0, then the two wave functions are orthogonal. But in this case, we've been given the limit for integration. So from minus k to k, and we have to evaluate this. Psi 1 is n1 into bracket a squared minus x squared, and psi 2 here is n2 x into bracket a squared minus x squared. Since they are in terms of x, we can bring the x here. So we want to evaluate this and integrate from negative k to positive k. If the result gives us 0, then indeed the wave functions psi 1 and psi 2 are orthogonal to each other within the interval of minus k and positive k. So now let's proceed. We can group this term to the other side, to the same side. So integral from negative k to positive k, n1, since they are multiplying, we bring n2 here and then x here. And a squared minus x squared, they are of the same term, so we can just square it, the x. So now, what do we do next? n1 and n2 are constant, we can bring them out. So integral from negative k to positive k, n1, n2, then x into bracket a squared minus x squared all squared dx. If we have a minus b all squared, we can simplify it by squaring the first term and multiplying 2 by a by minus b, giving us minus 2ab. And lastly, squaring the last term, which is b squared. So let's apply that one here. There. So we have our x there. So we square a squared, we square it, giving us a to the power 4. Then 2 by a to the power 2 multiplied by minus x to the power 2, giving us 2a to the power 2 x to the power 2. Squaring x to the power 2 gives us plus x to the power 4 dx. So now let's multiply x throughout. So we have n1, n2, integral from minus k to positive k, x by a to the power 4, giving us a to the power 4 x by minus 2 a to the power 2, giving us 2 a to the power 2 x to the power 3. X here to the power 1 multiplying x to the power 2 gives us x to the power 3. So x multiplied by x to the power 4 gives us x to the power 5, right? So dx. So now what next? Let's integrate. So n1, n2, integrating it, we are integrating it with respect to x. So if we have x to the power n, we are integrating it. The power will increase by 1. So x to the power n plus 1, and we divide everything by n plus 1. So let's do that. Integrating a to the power 4 x is our variable of concern. So we're getting a to the power 4, x to the power 1 increased by 1, x to the power 2, all divided by 2. So x to the power 2, all 10 divided by 2. So minus 2a to the power 2, x to the power 3, integrating it gives us x to the power 4, x to the power 4 divided by 4, right? So x to the power 5, integrating it gives us x to the power 6 all over 6. Our limit of integration is from negative k to positive k. So negative k to positive k. Now, 2 here can cancel, can go here 2 times, right? So let's rewrite that one. A to the power 4, x to the power 2, all on 2. This becomes minus a to the power 2, x to the power 4, all on 2, plus x to the power 6, all on 6, from minus k to positive k. Now we'll put in our upper limit, which is positive k, into the whole expression. So we have n1, n2, bracket wherever we see x, we put in k there, our upper limit. So x squared, so a to the power 4, then we put k to the power 2 there, all on 2, minus a to the power 2, wherever we see x, we replace it by k, x to the power 4, then it becomes k to the power 4, k to the power 4, all divided by 2, plus x to the power 6 becomes k to the power 6, all over 6, bracket close, then minus, bracket open. We now put in our lower limit, which is minus k. Wherever we see x, we put in minus k there. So a to the power 4 here, and then minus k to the power 2 give us positive k to the power 2, all on 2. Then here minus a to the power 2, then minus k to the power 4. Since the power is even now, is even, we are going to get positive k to the power 4, all on 2. And then here x to the power 6, since the power is even, replacing it by negative k gives us positive k to the power 6, all on 6, plus positive k to the power 6, all on 6. Remember, they are multiplied. So now let's simplify everything. We're going to get n1, n2. We have a to the power 4, k to the power 2, all on 2, minus a to the power 2, k to the power 4, all on 2, plus k to the power 6 over 6. So let's try expanding the bracket. Minus multiplied by a to the power 4 gives us a to the minus a to the power 4, k to the power 2, all over 2. Then minus minus gives us positive a to the power 2, k to the power 4, all on 2. Then minus plus gives us minus k to the power 6, all on 6. So let's see. We have minus k to the power 6 over 6 here, positive k to the power 6 over 6 here. So this will cancel that out. And then we have minus a to the power 4, k to the power 2 over 2, and positive a to the power 4, k to the power 2 over 2. This also will cancel that out. So we have positive a to the power 2, k to the power 4 over 2. And we have minus a to the power 2, k to the power 4 over 2, and they will cancel out. So this term becomes n minus 1, n2, n1 multiplied by 0, which is equal to 0. So the two wave functions, psi1 and psi2, are indeed orthogonal. So psi1 and psi2 are orthogonal to each other. For a quantum system whose state is given in terms of an orthogonal set of three vectors as psi equal 2 times ket 0 plus square root of 5i spin up, ket times spin up times ket spin up plus 4 over I times ket 4. So that A normalize this state. We have to normalize it. So our point of interest, the first thing we want to do is to calculate for the norm, which is equal to the absolute square, the sum of the absolute square of each coefficient here. So we are going to square 2, absolute square of 2 plus absolute square of square root of 5i, square root of 5i, absolute square, plus absolute square of 4 on I. 1 on I is equal to negative I. So this term becomes 4 negative I. So let's say negative 4i squared. But once we are dealing with absolute values, definitely this term will become positive. Okay, so squaring 2 gives us 4 plus squaring this term right here. If we square I itself is equal to square root of minus 1. So if we square it, it's going to give us minus 1, making this whole term minus 5. But the absolute sign will cover all of those effects. So we are going to get 5 here plus square of this is going to give us minus 16 bar. Since we are dealing with absolute values, it should be 16. So now let's add everything up. So in simple terms, once you are dealing with absolute values, don't let this complex term here confuse you. So once we take the absolute value, generally it will cover everything. So norm equal 4 plus 5 plus 16, and that turns out to be 25. Now that we are done with our norm, we calculate for our normalization constant. And normalization constant equal 1 over square root of norm. And our norm is 25. So this is going to be 1 over square root of our norm here, which is 25, square root of 25. Going to give us 1 over 5. Square root of 25 gives us 5. Right? Now that is the second step. The first step we calculate for our norm. The second step we calculate for the normalization constant. And the last step is to multiply the state that was given to us, to multiply the normalization constant throughout. We were given psi, equal to, yeah, this is the term. So we are multiplying the normalization constant throughout. Let me bring it here over 5. Multiplying everything. So 2, 0 plus 5i spin up plus 4 on I, 4. Okay. So if we multiply 1 over 5 throughout, 1 over 5 multiplied by 2 is only going to affect the coefficient. So 1 over 5 multiplied by 2 is going to give us 2 over 5. And you write everything as it is. Plus 1 over 5 multiplied by 5i is going to give us, this should be square root of 5i. So square root of 5i all on 5, spin up 8, plus 1 over 5 multiplied by 4 on I. So it's going to give us 4 on I, 4 on 5i, 4. Okay. So this is our normalized state. Then how do we prove that? Just take the coefficient, the absolute square of the coefficient. So we have 2 over 5. We are taking absolute square plus square root over 5 of 5i on 5 absolute square as 4 on 5. 4 on 5i absolute squared. So squaring this gives us 4. Squaring this gives us 25. Plus squaring this is going to take care of the I and the square sign. So we are going to get 5 over 25. Plus squaring this gives us 16. Squaring this will give us 25. So that should give us 1. So normalized. That is it for this problem. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.